Hello, we're going to be talking about mathematics for machine learning. I'm very interested in this subject, it's one of my favorites, and I happen to be working in the field of machine learning and artificial intelligence, and I like maths as well. So let's dive in and see what this book has to offer. And this came out in 2020 or 2021, so the book has been around for a few years now. It's got very good feedback, overall great reviews, and let's see. So I'm right now just sharing the PDF version of this book online, and it's available for free. So if you go to Google and you just search for mathematics for machine learning, you will land on the site, and you can download this PDF book and follow along, right? So I'm going to be covering some of it initially just by sharing the PDF directly like this, and then slowly we'll see if I can also do some writing and explain some of the concepts. So hopefully you find these videos useful for learning machine learning as well as the mathematics for machine learning. Okay, so I'm going to scroll down. So these are the authors of the book: Dijzenrath, Faisal, and Ong, and they are professors in the United Kingdom in universities. So let's scroll down a bit and see the table of contents. So I'm going to move my camera a little bit here as I scroll down. Okay, there. And so let's zoom in a little bit. Okay, so first they cover the mathematical foundations, and that's part one of the book. And in that, as you can see, they give some tips about how to read the book and so on. And then the first thing is linear algebra, right? So linear algebra is one of the foundational math topics for learning machine learning and AI. Okay, and in that you might have seen some of these in high school mathematics. Actually, this book does have a prerequisite of high school level mathematics, which means you should have encountered vectors, matrices, at least those two from the standpoint of linear algebra, and then rest of it is covered here, like vector spaces, linear independence, and so on. And then the third chapter is analytic geometry, and that's where you go a little bit more into linear algebra, what we learned, and then learn things like orthonormal bases and orthogonal projections and so on. Chapter 4 is on, let me scroll up, is on matrix decompositions. So this is again very important. All over machine learning we are going to be using a lot of these decompositions, matrix decompositions, and then determinants and trace. Hopefully you've done this in your school level a little bit, but we'll also review it here. The book has good materials. So let me scroll down, then let me a little closer so you can see eigenvalues and eigenvectors. Maybe this is the first time you're seeing things about eigenvalues and eigenvectors. Then Cholesky decomposition. I happen to click on it, so let me go back. Okay, there. I'll be careful not to click. So here is Cholesky decomposition, then singular value decomposition. And the good thing about this book is we will see in part 2 that all these actually are very practical and how one can apply that for machine learning. Okay, so after chapter 4 we'll go to vector calculus, which is chapter 5. This again, if you have done single variable calculus in your school, that will be considered a prerequisite for it. If you've forgotten some of it, you can go to Khan Academy and refresh some of the basics, right? But this chapter is directly about vector calculus. This might be the only chapter which I feel you will need more prerequisite than the others. The others are relatively easier concepts to learn, especially linear algebra and matrices and other things, but calculus, maybe at least differential calculus, is going to be required. So if you're a little bit rusty on your single variable calculus, I would encourage you to look at either Khan Academy, or you can also do some of the MIT OpenCourseware calculus lectures. Okay, so that's about vector calculus. This will be very important throughout machine learning and AI and in deep learning and in all aspects. Then we'll do probability and distributions, especially Bayes rule, Bayes theorem is important. It will be used in many places. And after that, finally, this continuous optimization. Again, you might have done maxima and minima and local maxima, local minima in your high school. So this continuous optimization is basically more advanced concept of that, right? So with that, these first 7 chapters, actually pretty much 6 chapters, will cover all the mathematics that's going to be required. But as we can see, this is itself almost 250 pages, right? The book is total 400 pages, so it's going to be a lot of material. But the good thing with the book is it teaches us only what we need for machine learning and not a whole bunch of other math concepts that we don't need for machine learning, right? And then the book goes on to say part 2. So the part 2 of this book is basically the central machine learning problems, right? So where we actually start having data, right? And then we start doing things to the data, and we try to predict from the data, or we try to infer from the data. We basically do information extraction from data, right? So how data becomes information, that's kind of the more general concept. So the central machine learning problems, it has chapters covering those. So the when model meets data, empirical risk minimization, and then like again I click the same thing, probabilistic modeling and inference, and so on. Let me go back. Sorry about that again. Then here we cover some directed graphical models and so on. And move the camera again. So linear regression is one of the basic concepts in machine learning, so we'll learn about that. And then we'll go into dimensionality reduction with principal component analysis, or PCA, right? So this is very useful for reducing the dimension of our data. We'll learn what that actually means when we get there. And then density estimation with Gaussian mixture models, and finally classification with support vector machines, right? Even though support vector machines are a little bit older concept, they've been around more than like 30 years, I guess, by now. This is 2024, or even probably even longer than that, maybe 40 years or so. There's a lot of research that was done in the, I think the 80s and 90s is one of the very famous traditional machine learning algorithms. Not sure how much it is used today in industry, but it's got very nice mathematical properties, so we'll be learning about that. But personally, I'm very excited about this book, and very happy that a book like this exists today, because if you want to learn more from more advanced books, like for example Christopher Bishop's machine learning book, or more advanced mathematical graduate level textbooks, we at least need this much of mathematical background. And I'm glad that there is this kind of a bridge book or a course that's available for us. And typically I would think that in a college setting, this book might be covered in 2 semesters, and so that's kind of about a year almost. So since I am myself a self-learner, an evening learner if you want to call it that, evening and weekend learner, and I have a full-time job, I'm going to be covering this as much as I can, go slow. Maybe there are things that I myself forgot, so we'll see how it goes. But I'm just very happy and excited that this book is available for us to learn from. All right, thank you for listening. I'll see you in the next video.